Okay, cool. So let's begin. How to get an internship. So I just want to begin this talk by saying if you're a first year, if you're a second year, if you're a third year, this course isn't going to be exclusively directed at any single one of you. I'm going to go through my experiences and give advice for people from every section, or however you can classify first, second, third years. So to begin with, let's just maybe go, yeah, awesome. To begin with, I am aware that as someone who starts university, and you hear about all these people getting internships, and you might have seen the movie The Internship, and you presume that everyone who gets the internships are geniuses. That's what I thought, and I was petrified, plus I really wanted one, but I really thought it was impossible. To start off, I just want to relax you all by knowing that I am not special. I knew zero programming coming into my degree. I did not study and prepare beforehand. But when I came into my degree, I was really focused on wanting a result, and that was an internship, and that also was further goals of wanting to make a startup, etc., etc. So I came in as a focused individual, and I met a bunch of guys in my first year, and they told me, oh yeah, we're going to Google, we're going to Microsoft. And I met these guys, and I was like, whoa, rewind. Like, you can actually do that. You can actually go to Google, you can actually go to Microsoft. I was blown away that people were sitting in my circle that were geniuses by my calculations at the time. So I glued to these guys, and I followed them around, and I said, please teach me what to do. I will do anything. Teach me everything you know. And they taught me, and I did the teaching. I acted upon the teachings, and I ended up interning at Palantir Technologies after my second year of university, and after my third year of university, I interned at Microsoft. Cool. So I'm going to go through the topics of this talk. It's going to be three major topics. The first one is padding your resume. So basically aimed at everyone who doesn't have a single drop of programming work experience. What can you do to your resume to ensure that it actually gets the position, like it actually gets accepted by the HR rep and gets the interview? That's what that part's going to go through. Second part is learning the tech. So what I really wanted when I did this, when I was preparing, was I wanted someone to just give me a list, like give me a list of what I need to know. If I learn this list, then I'll be good. And that's what I wanted, and I ended up getting that. So I'm going to go through that list and explain some things about how you can actually continue to learn all the things. So there is still a problem that can happen, that you will do your interview and you will do well, but you will still fail. This happens to so many people, and it's like the ghost in the room. No one actually knows why. And I've had my friends fail, and I sat down and tried to teach them, or tried to explain to them what to do. And in that process, I kind of realized some things that I was doing that actually helps you to not fail in those situations. I'm going to get to them later, so let's just start on topic one. What these big companies want is not for you to have a bucket load of actual programming work experience. They don't actually expect that, because you're just a university student who just finished high school. Like, what experience do you have? And something that it's good to have like really good grades on your CV, but what they're actually looking for is passion. They want to know that you care, and if you can somehow show them that you care, then they'll look at you and be like, yeah, this guy's good. This guy has, whoa, this guy's worthy to be looked at. And so what can replace work experience on your resume? So I have identified three things that is all achievable within your first year of university. The first thing that you can add to your resume is personal projects. Personal projects are excellent because they show that you are willing to do more outside of the university work. The second thing is competitions and awards. And the third thing is community involvement. I'm going to go into each of these, dive down deeper into these right now, just in case you want to know more about it. So, specifics on what to do in your personal projects. It could be as simple as, if you're just doing introduction to program, you've learned Python, you've learned something, just think of something, a program you could make, and do it outside of the university learning realm. That's all you need to do. If you want to do a bit more creative, like I personally, in the summer after my first year, sat down for a month and just went on Android tutorials and learned how to make an Android app. I didn't even finish the app, but I learned how to make it. Like, it wasn't published. I had it on my phone and I had it on my resume, and if anyone asked me, I'm like, yeah, here it is. Like, it exists. Like, that's all you actually need to do. Have a project to show that you're doing stuff outside of university. Next thing is competitions and awards. That might have scared a few of you off, thinking I don't do competitions, and by God, I do not win awards in competitions. And the important thing in this one is you don't actually have to win. You don't even have to do well. Like, remember, what we're doing here is padding your resume. Padding your resume is, making it look bigger than it is. So what you need to be doing is just signing up to a lot of things so you can just chuck them on your resume. And competing and just participating in competitions is enough to achieve this. And it's really important, and it's really good. Like, it's a really good indicator that this student cares. If they see a competition, the girl or guy looking at your resume will be like, all right, this guy cares, obviously. He's, someone who doesn't care, doesn't go and tries to compete in a coding competition, doesn't exist. Like, all right, next thing, sign up to everything. This is talking about community involvement, and this is more telling the interviewer that you care not just about yourself, but you care about programmers in the world in general. And that's kind of what this community involvement explains. Examples is when I was in first year and I was trying to pad my resume out of nothing, every time I saw a post on the computer science forum saying, we need peer mentors, we need ambassadors, we need student teacher committee members, we need come sign up to our club. I just sign up to everything. I overloaded myself completely and I had to cut a few of them back. But the point is just sign up to everything. And just like programming competitions, sign up even if you don't care. Like, it's not about you doing what you like. Like, it's first year. Like, a lot of us do things that we don't like. It's like maths and stuff. Like, I like maths, but some people don't. So really, sign up to everything because you want to have a full resume. And all of this information is enough to pass and get and land the interview. And that's kind of my interview preparation. The thing to note is, it seems like a lot, but if you have a whole year to start, if there's any first years here, like you got a whole year to just do all this stuff. Like, no one's expecting you to get an internship right now, but right now is time you could utilize. All right. Anyways, let's move on to the next part. So you have prepared your resume. It is all good. It's ready to go. And now you've landed an interview, but you've got no idea what you need to learn. You know algorithms are involved, data structures are involved, you should do mock interviews, and that's kind of all the information you have. But when I was a first year, or when I was starting second year, that wasn't enough for me. I wanted to know, give me a bloody list and I will do everything and I will pass. Like that's what I wanted. So from a few books and from speaking to the friends of mine that I mentioned earlier, I got that list. So let's start to go through them. There are 3 different areas. There's data structures, there's algorithms, and there's just other kind of miscellaneous concepts. Data structures. Data structures are the crux of it all. Algorithms are built on data structures. If you know your data structures, you will know it all. So I'll explain this. So when an interviewer comes in and they ask you a question, so your job is to listen to that question, figure out what data structure is going to be used that can answer the question, and then you think about what algorithm uses that data structure. But it all starts with data structure. You can't just think of the algorithm and think, what data structure does that use? So data structures are the most important thing. And on top of that, you don't just knowing what an array is and knowing what a linked list is and understanding, just knowing, an array is just, some memory stored in contiguous memory and linked list is just pointers. Just knowing that isn't enough. When I say learn data structures, I'm saying know the complexity for insert, for delete, for find, for every single one of these. And because that's what the interviewer is going to be asking you. So the data structures will be linked lists, binary trees, tries, stacks, queues, vectors, and array lists, and hash tables. If I'm going too fast, these slides will be put up so you can go back through, just in case any of you are frantically writing down that I can see. So I know there's more data structures, but this is like the absolute, staple. If you get these, you will have enough. There's others that could give you extra bounty points, but this is really enough. Moving on, algorithms. So algorithms kind of follows on to my little speech that I had about data structures, but there are a list of algorithms that are required, or not really required, I'm going to say. It's more like if the interviewer asks you to do one of these algorithms and you don't know it, you're going to fail. So that's why I say it's kind of required. So these are the algorithms that you kind of really should know, and you'll be in shit creek if you get asked and you don't know them. So know breadth first search, how to actually implement it, because they might ask you to implement breadth first search, depth first search, binary search, merge sort, quick sort, and just in general how to implement tree insert and find. Cool? All right. Concepts. These don't need too much of a lead-up explanation. These are just extra things that go by the exact same explanations that I've given for data structures and algorithms. So bit manipulation, it's not used much in the everyday programming, but it's one of those things. If they ask you and you don't know, you're in shit creek. So learn bit manipulation. Singleton design pattern, factory design pattern, memory, stack versus heaps. Maybe with this one, this is kind of another thing where just knowing what it is isn't enough. Maybe try and just do a bit more research about some extra content, just in case they quiz you on it. Like, what can the heap do over the stack? Just have, because stack and heap is pretty important. Recursion, and last but not least, the most important, big O time. Big O time is the center of all algorithms. It's the center of what they want. Like, an interviewer might presume you know how to write code and might presume you know how to answer the question, but really, interviews are about, you want to nail the problem that is solved in the best time. So if you're a first year and you haven't heard of Big O time, that's okay. I actually heard every single one of these, and I knew I had heard of 3 of them, and I shut myself. I didn't know. I actually asked my friend who showed me the list, and I'm like, "Do you actually know all this? This is crazy." And he said, "Yeah, this is important." So I'm telling you, it's important. And to learn this stuff, I personally believe that, a friend of mine has kind of confirmed to me that isn't this the way you're supposed to learn it, but this is how I've always thought. So before you practice the hell out of mock interviews, just learn all the data structures and the algorithms. Because when you get a mock interview, or just also when you get any interview question, what you're actually doing is you're suddenly searching through your memory, trying to figure out the right data structure and then figure out the right algorithm that you have learned in the past, or you have previously learned, and then apply it and then figure out an algorithm. So if you start practicing questions, it's useful, but I recommend learning all data structure and algorithms first so you can apply them to your actual question problems. So these books were recommended to me by those mystical group of friends, and I immediately, next day, ordered them. So the first one I'll talk about is Algorithm Design Manual. I ended up learning all of the content of ADDS and ADSA, plus more, basically everything that I needed from those lists that I gave in this book. The first 10 chapters of this, I read it every night. I spent about a month, 2 months reading this. I had all the knowledge, and this is what I'm saying. If you want just a set list, do this and you will know it. I'm saying 10 chapters of this, do that, you will know it. Simple as that. Algorithm Design Manual, get it, it's great. Next one is cracking the coding interview. Name of this talk. I'm not stealing the name, it's just a good name. Ragav actually recommended that I call the talk this. Yeah, right. So this is my Bible of interviews. So learning all about data structures and algorithms is one thing, but being like a pro at just understanding companies and all the different questions they can give you, it all starts with this. That whole list of all that stuff that I gave you is actually a table from this book. Like, this goes through behavioral questions that Facebook, Microsoft, Google, Amazon give you. This goes through what you should do for the whole year leading up to your interviews in a step-by-step, month-by-month breakdown. It tells you all the things that you need to watch out for. It is the Bible. But that's just the first 3 chapters. The rest of the book is 150 questions that goes through 15 topics, I believe, 10 questions each. And it has this like awesome setup that like I've used this for both the times I have gotten my internships. I have sat down the one with my friend Conrad, and that's when I got Palantir. Second was when I was with Fireboard. Me and him used this book, and I personally, like there are tons of ways to practice questions, but I actually only did these questions. That was the only practice that I had. Yeah, every now and then I would go on a website and do some hacker rank things. If you've heard of them, there's websites where you can do practice coding interviews, but like the Bible, it's being used to hell because it's just so good. Like I'm in the middle of going through it again because it's my favorite interview book. All right, anyways, I need to keep going. Cool. So I will say this once and again at the end of the talk. All this preparation means nothing if you don't know your algorithms and you haven't practiced coding questions. It is so important that you practice. You need to have this like memory of like array lists, insert time, and you need to be like, boom, I know it. You know, like practice and just learn it, because there's no easy, cheap way of getting accepted for an internship or an interview. It's literally you will, the more you know, the more you'll just be confident to just fire off information. And the only way you can do that is to practice. Sorry to say, I know some of you might have come here thinking, I hope there's some easy way of getting an internship. There isn't. It's a lot of work. But I'm telling you the work, so at least I'm telling you what the work is. At least it isn't some world of like, I know there's lots of work to do, but I've got no idea what it is. I'm telling you what the work is, so that makes things easy for you guys. Cool. All right, last part of the talk. You have done your resume. You have done your algorithm coding practice. You go into the interview and you still fail. You answer the question. You don't screw up the code, but you still fail. This is heartbreaking. This is the fear of all programmers. Every time I know that I have killed an interview, I am scared of this happening, of failing and not knowing why, and it happens to so many people. So this, right, so why do you fail? You can fail for a number of reasons. There are some obvious ones like, oh, the interviewer was having a bad day, or just like, I don't know, let's say you're unlucky enough to get a really racist interviewer. Like it happens rarely, very rarely, but like, yes, unfortunate stuff can happen and you just don't get it. But a large majority of the reasons why you fail in this way, I believe, is of 2 reasons. First one is not enough communication. Now, communicating in an interview is completely alien to what you've done so far. All of you, when you've coded so far, you have sat in your own head, you've programmed, you've not talked to anyone. Once you've solved it, you'll be like, oh, it works, and then you walked away, right? You haven't actually said any words. You might talk to your friend about something else. But like, the point is like, communicating in an interview is really weird. And I'll go into that in the coding portion of this, so I'll go into that further. But the second thing why you might fail is answering the wrong question. This is so easy to do. It can come in, I think, 2 forms mainly. One is that you misinterpret the actual question about like what's the input coming into the function and what's coming out. Like you misinterpret that and you just answer the wrong question. And the other one is you might know the question, but you answer it in the wrong time complexity. So you write an n-squared algorithm where there exists an n log n or something like that. And that can still be considered a wrong answer, and that can still be a reason why you fail. So let's go into this. So the strategy I use, I have a very specific strategy that really focuses and drills down and stops these two things from happening. It might seem simple at first because I've broken it up into 4 steps, and everyone, or not everyone, but I have heard often of people breaking interviews into steps, but this strategy has a little twist that I'll get to, and you'll see it a bit later. So the strategy is break your interview up into 4 steps. First step is question validation, which is making sure you've got the right question. Second part is algorithm design, making sure that the complexity of the program that you're about to write, you haven't written it yet, that you're about to write is of the right complexity. And the next part is implementation, the actual writing of the code. I'll go into all this after this list off. And the last part is testing. Cool, so let's dive into it. Step 1, repeat the question back to the interviewer. So like an interviewer comes to you and asks you a question, and you can be like, yeah, I get it, straight away. You're like, oh, duh, that's that algorithm. And you just say nothing. You turn around and like, blah, 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 blah. You write it up, and then you say, yep, done. And interviewer says, thank you, and you leave, and then you get an X. And this, don't do this. Don't be that guy. When you get a question, even if you are 100% certain that you understand the question, repeat it back to them. Say, all right, so I'm writing a function that does this. And actually get a pen, definitely do this. Do not skimp out of this because you're nervous or something. Just remember to do this. Get input, like make up some input, and then say what the output's going to be. So basically, like give them a basic input and output of what you think the question, like the function is. So confirm it with them, and then before you move on to step 2, like this is that little that thing I was saying that is my little secret to my spice of how to do this interview. Is before you move on to every step, you always go back to the interviewer and you ask them, is this correct? You actually say to them, like, all right, I've got this. This is the function I'm about to solve for you. Are you okay with this? Can I move on? Is this good? And they will give you, this has happened to me. I've literally like said the algorithm or said the problem and say, oh, all right, that's what I'm going to do. And then the interviewer will say to me, no, I actually wanted to do this in this case. And I'll be like, oh, that's a different problem. Like, and I only caught that and passed that interviewer because I repeated the question, are you okay with this? Cool. So you said that, he says yes, cool, you move on to the next step. Algorithm and complexity. So I personally, some people try and code and figure out the algorithm as they're coding and they kind of mix it all up into a big blob. But I always figure out what the algorithm is and I figure out what the complexity of the algorithm is going to be. So they give me a question, I think, yeah, I can do it using this and it might be n squared. And I'll explain how my algorithm works, and the interviewer looks at me and they say, oh, sorry, I'm jumping the gun, sorry. If I just did that, if I just designed my algorithm that had n squared and then I moved on and just started coding, that could lead down the end of the line to them saying, no, he got the wrong, he did the wrong thing because he did the wrong complexity. There was an n log n solution, a big O n log n solution, and he just didn't do it. So when you design your algorithm in front of them, and this can be verbal, only verbal, like, yeah, I'm going to do this, you can say, or you can draw up, like, it doesn't matter. Just design it in any way you can, and then tell them, I'm going to do this. Are you all right with this? This is like the step that's going to repeat after every single process. Always confirm back to them, are you all right with this? Same reason for the validation of the question, asking, are you all right with this? What this does is gives them the opportunity to like let's say you were doing this n squared solution and the interviewer looks at it and thinks, oh damn, I really wanted them to even at least tackle the n log n one. And the fact that you say, are you okay with this? They might be like, actually, could you please try and think of a better complexity? And they'll just tell you. Of course, you might get the interviewer who just is being, a real prude that day, and they say to you, "Oh, sorry, I can't really give you any information. You have to do it by yourself." That does happen every now and then. If that happens, suck it up. Just really try. But a large portion of the time, they won't, and they will tell you that yes, I want you to try and figure out a better one. So okay, cool. So you figure out a better one. And you have confirmed with them that, are you okay with this? They say yes. You move on to the coding part. Now, I kind of briefly went over this when I mentioned coding the first time. This is the actual part where you code it on a whiteboard in front of them. You do, if it's a tech interview, you will be coding in front of them. I've had one where I was on paper in front of them, and I've also had another, there's the screening one where you code on a screen and they see it on lines. But in general, this is the coding portion. And all right, so the hard thing about this is that, when you code in the coding portion, you're not actually coding a proper program. There's probably weird syntax errors. You're not actually doing proper coding. What you're doing in this part is, I always visualize it as I'm putting on a little play for the interviewer. It sounds weird, coding in a play. I didn't come to do computer science to be an actor. What you do is, this is the way I do it. If you want to employ it, you can. But this ensures that I don't get hammered down with that not enough communication red flag. I do not want that. So I'm petrified of getting done for that. So what I do is, as I write every line of code, beforehand, or maybe before every 1 to 3 lines of code, I'll turn around to the interviewer and be like, I'm going to write this code. It's going to be a for loop that has this, this, and this. And I'll look at him and I'll just turn around and do it. And then, presuming you're knowing what the algorithm is, and this all comes from that preparation. So all of this, by the way, all presumes you know your algorithms and data structures, because none of this is this is post that. This is presuming you have all the information. Okay, so you follow these steps, you get to the end, you've been asking and writing and asking, or telling and writing, and you get to the end, and same thing, are you okay with this? This one doesn't always hit home straight away of why you should ask it here, and the reason why is because what if you didn't write enough code and they actually wanted you to see a bit more? So if you say, are you okay with this? They might turn around and say, actually, could you also just write that helper function over there? Because they just want to see you do more code. And you don't want them finishing the interview thinking he didn't write enough X. This whole process of asking, are you okay with this, really just ensures that you're not getting any X's along the way. Cool. All right, step 4 is step through your code. No, there we go. Sorry. Step 4. What is going on? No, what's going on? Step through your code. Talk before you write. Okay, all right, sorry. Step through your code was actually step 4, which is the testing phase. I might have confused you guys, sorry. So we got question validation, we've got algorithm design, we've got coding. Now the final stage is the testing. So testing sounds boring, it is boring, but you got to do it because it shows that you're actually being a good coder. So what you want to do is step through the code, get a basic input, maybe the one they gave you or the one that you said at the very start, and just make sure that your code works. Now, an important thing to note here is something that happens quite often with a lot of people doing interviews is you might find a problem like, oh my God, my program completely breaks with it when a negative number gets passed in. I did not think of that. Or you might think of some case where your program doesn't work and your immediate response, it's like a fight or flight reaction, is to jump up and rub out something and start trying to add, and you put arrows in and you start editing the code. Don't touch the thing it's written, okay? If you find an edge case when you're testing and you realize that your code doesn't work for some case, they want to know that you have identified it and you know how to fix it. That's all they want. They don't want you to go and like mess up the freaking page and waste time, because they got other questions to ask. So if you realize something doesn't work, like, oh, you haven't checked for the null case, you just say to them, oh, here, I just put a check for a null case up there. That's all you need to say to them. They just want to know that you're thinking about it and you know how to handle it. same as always, end this part and end the coding interview with, is there anything else you want? And they might ask you to test a specific case. Same reason as always. They might have wanted something that you haven't done yet, and you don't know what that is, but just ask. Cool. So, are you okay with this? I kept repeating it constantly, and that is the magic of my little strategy I've invented. The reason why I believe "Are you okay with this" works is because I think it kind of, this is my little happy little thing, thinking I've outsmarted everyone in the world. What I think it does is, or what I presume it does because it's worked so far, is the situation, let's presume that you have said, "Are you okay with this? Are you okay with this? Are you okay with this?" And they said yes, 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 and yes. But let's presume that that what you have done is actually wrong, okay? And they would have to go to their little scorecard at the end and give you a cross. But they've just said yes to you that you're correct 4 times in a row. They would have to be a real douchebag to be like, I said yes, but it's actually no. It's like playing on their psychology. Is that even the right sentence? I'm not a psychologist or English, so I'm a computer scientist, so don't hate me on that one. But I think it really plays on their mind, and it kind of twists their arm into saying yes. If you've gotten them to say yes 4 times, they're used to saying yes, yeah, yes. Yes. So really that's why I believe this "Are you okay with this" strategy works, and I believe it does. I've talked, every time I tell people about interviews, jump onto this. Oh, dude, you got to know this. And all right, so that's kind of the end of it. But I will reiterate, I told you I would. Know your algorithms. You cannot get this far and even get into any of these situations that I was talking about in that breakdown if you don't know your algorithms. And like I said, this is a great way to ensure you know it. 10 chapters, that's all you need. And this is a talk for the Competitive Programming Club, and they are doing mock workshops, and they're going to be helping people learning algorithms and stuff. So there's communities here that will help you. So if you want to practice with people, you can come here. You just get involved and just start putting the time in. Cool. So that's the end of my talk. If any of you want to contact me, there's my email, there's my name, Ravi Hammond. Cool. Thank you very much. Any questions? Yes?
From what I've heard, you seemed really motivated when you went into first year.
Yep.
Is that right? Could you talk a bit about the reason behind your drive?
Okay. All right. Well, I might have to tell you a bit of my life story to explain that. Sorry, guys. Story time. I went through year 11 and year 12, and I failed. I didn't care about life at all. I cared about life, but I just didn't know what I wanted to do. And all right. Story time's over. No. So I went through the next 4 years of my life just playing computer games and not really doing anything. And I was kind of, And the funny thing is, I think what made me get that huge drive was I did nothing for so long, but I didn't have any parents trying to force me to do something. So the only way that I could ever do anything in my life is if I stood up and be like, yeah, actually, I should do something with my life. So I had a cousin who was, married, and he was an electrician, and in my mind that was he's made it, because I was doing nothing with my life. I was 22, did nothing. And I realized I was working at a bar, and I thought I got to do something. I have to do something with my life. And that was kind of a turning point that really just started me down this road. I actually I started a pre-book course to be an electrician, and then I was actually playing a lot of Minecraft at the time, and I was doing tons of redstone circuitry stuff. I was just trying to I got really obsessed with that, and I thought, man, I'm really good at this. I could be an electrical engineer and do circuits. So I came to university, and I'm like, how do I be an electrical engineer? And then I started the process of doing my year 12 maths again, and to get in. And then in that process, I found out that my mate's little brother started coding Minecraft, and I thought I was the Minecraft guy. And I'm like, if he's coding, I've got to code too. So I started teaching myself how to make a mod for Minecraft, and then I'm like, man, I love programming, because I realized what I liked from the whole redstone electrical stuff was actually the problem solving, and I guess I loved it straight away. I realized this is what I wanted. It's not the electric stuff. I just love the problem solving. So yeah, that's why I came in, and I was the most eager first year after that. So that's kind of, yeah, what happened to me.
Thank you.
Anything else? Any questions? You first.
Any advice on who to apply for? Do you just send out resumes to everyone you can think of?
Who to apply for? Okay, I kind of did some Google searches, asked some people that were in the computer science club. I asked them, what are all the, because at the time I really wanted to go to Silicon Valley. That was my goal in first year. So I just thought every big Silicon Valley company, and really my advice to who to apply for is just any big company, and more than 4 when you start. You want to do what you want to do is apply for so many companies that if one of you fails, you don't care. You're like 20. That's the kind of mentality, because it'll relax you when you do the interviews, because you're not like stressed that you're going to fail this one and your only chance. So it's really like a lot of companies is my advice for that. Cool. You're next. Yep.
I just wanted to ask, as a first year, when did you start learning, or when did you start knowing everything on that list that you mentioned earlier today?
So I actually started a month before my second year started. So so my progression was, first year was all that resume stuff, the resume crap I was talking about. Then in the summer after first year, I was trying to make a project because I'd never done anything. I needed a project. And straight after that, then I thought, all right, I've got the resume stuff. And a month before second year started, I started reading this. And I think a week into it, maybe like a month into second year, I'd finished the first 10 chapters of this. So starting second year, I knew all that list. Yep. Yep.
Did they, it might depend on the company, did they ask many other questions about your motivation to applying and work there and stuff?
Yeah, so those interview questions I actually haven't covered. Coding questions are one portion of it. There are other kind of categories. Behavioral questions is what they are called. Basically, questions that ask you about your life. Tell me about this situation, how you felt, what was your action you took, and what was your result. It's kind of called a STAR question. And basically, if you just Google behavioral questions, there's tons of resources online about how to deal with them. But yeah, all the companies I have, maybe it's usually like the end or the very start might ask you some behavioral questions. Yep.
Thanks.
Cool. Any other questions? Yep.
For complexity, were things like big omega or little n or little o or big theta,
Yep.
those kind of things important, or you said just big O?
I'm going to say no, only big O is important. That's all they care about. If you're applying for something that is very, I don't know actually, let's say Jane Street maybe, that's like a company that deals with trading. So because there's a lot of maths and statistics involved, maybe they might ask, but to be honest, probably not, man. Big O is what you need. Yep. Cool. Any other questions? Yes.
Did you enter some competition?
Sorry, say that again. The competitions. Did I compete in competitions? Is that what you asked? Yes. Yeah. So I didn't actually talk about that. That group of mates that I befriended in my first year, me combined with them ended up competing in 2 hackathons in my second year, and we ended up winning both of them. We ended up pulling all-nighters for both of those events. All of us were kind of crazy. But yes is my answer. I actually haven't myself competed in any competitive programming events, official ones. I've done some university ones, but all the competitive programming I've done have all been hackathons. And the difference is, in case you didn't know, so competitive, I don't know what the official name for it, but I'm going to call it competitive programming is when you basically do interview questions like this really fast, and this is what this club is about, competitive programming. Hackathons are more companies come together and they get a group of developers and they say, we have these 4 problems. Can any of you create something that can solve our problem? And it's more commercial, and usually, like it involves pictures, and you have to like present to them and stuff. And it's more of like a business thing. But yeah, so I hope that answers the question. Yep.
Were your friends second years as well?
Yeah, so they were actually in the year above me, which is why I kind of clung on to them, because I thought they know more than me, so I wanted to make them my friends. Yep. Any other questions?
Do you have any resources for learning more about big O notation?
So there's some really good big O notation stuff in, I think, the first chapter of this book. Like I said, it's a really good book. And it goes into some more of the specifics of, what was your name, sorry? No, sorry, behind you?
Oh,
Bale? Yeah, so Bale was asking about some other parts of Big O Mega, and also, I forget, Little O and stuff. This goes into all of that in depth and shows you proofs of why they work and stuff. So yeah, algorithm design manual.
How much is that?
I think I probably paid too much. I paid like probably $60 off online, but you can probably get, I did try and find the cheapest, but like you can download it for free on, like as an e version or whatever. So, I loved it because I can just get a light and whatever and just read in bed. So like it's kind of harder to do unless you have a Kindle. Like they're alright, but yeah. Any other questions? Cool. What time? How far did we go?
It's 5 minutes to.
5 minutes too. God, I think we kind of made perfect time there, didn't we? All right. Thank you, everyone. Let's turn this off.